Okay, in this question we have ICl plus chlorine going to ICl3. The delta G of the reaction is -17, which is interesting because it's not spontaneous looking based on the entropy where we have gases going to a solid, but we still have a negative delta G, so it must be highly exothermic. But what we're looking for in this question is, what is delta G at a certain situation? So the delta G, again, not at standard condition, tells us what is going on when we're at, in this case, 1 atmosphere, we have a pure solid. So we have some products, we have some reactants. Where is it going to go? And it's saying it's going to go towards the right. But what about at a certain situation? Where, because generally we don't stay at standard state very long. And so it's just kind of a reference point when we're building equations or hypotheticals. So delta G without the not is a better representation, but we have to know Q, right? So it's going to reference Q. So we're going to use delta G is equal to delta G naught. So that's still part of our equation, plus RT. Notice a plus now, not a minus, natural log of Q. So first thing we have to do is Q is equal to what? It's products over reactants. This case, they're all 1 to 1 to 1. So we don't have any squares or cubes in it, but we have a pure solid. So we actually just have a 1 on the top for the products. And then we have ICl and Cl2. No squared or cubed because it's 1 to 1. So in this case, we are given ICl is 0.02 and Cl2 is 0.001. So Q is equal to 1 divided by 0.02 times 0.001. So 50,000. Okay, everything else is plugging it. We're given temperature in Kelvin. That's a big thing to be aware of. R, again, we got to convert to kilojoules. So I'm going to say delta G is equal to my negative 17.09 kilojoules per mole plus 0.008314 kilojoules per mole Kelvin times 298 Kelvin times natural log of 50,000. So I'm going to do this second half first. So I'm going to say 0.008314 times 298 times my natural log of 50,000. And I get delta G equals negative 17.09 plus 26.81 kilojoules per mole. I add those together and I get positive 9.72. And it's supposed to be kilojoules per mole. So if you convert it to joules, make sure you go back to kilojoules. So in this case, the delta G is positive. So it's actually going to go towards the reactants because we have such small amounts of reactants that we've passed the equilibrium point. We've gone too far. And so now we got to shift back left towards the reactants. Okay, so 9.72. There we go.